This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. Welcome to day 1 of 5.6 Graphs of Exponential Functions with base E and applications. So check this out. We've got example 6. We're going to graph each of these. And basically what I'd like to do is to introduce you to your newest parent function. This is f of x is equal to e of x, and we're going to have variations on that. We're going to have e to the negative x, and e to the negative 0.5x, and e to the negative 2, or 1 minus e to the negative 2x. So the parent function is e to the x, and as you might expect, the input is we've got a standard input here, and there's become the exponents with the base e. You've got to use a calculator to do most of these. E to the 0 is just 1, and I'm going to track 0.4 and see where it goes when we track 0.4 and 2.7. We'll see where they both go as we dilate this or shift this graph. Anyway, these are the values, and if you plot them and connect the dots with a curve, it looks like this, very much like an exponential function, except it's slightly steeper than, say, e to the 2 to the x. E to the x would be 2.7, and so then it's just that much steeper. Now, how do you compare f of x and g of x when g of x is e to the negative x? Well, it's the same thing as f of x, except you just have the negative of the input. It's a horizontal dilation of negative 1, also called a horizontal reflection. You're reflecting it over the y-axis graphically. So, negative 2 as an exponent becomes positive 2, e squared. Positive 2 becomes negative 2, e to the negative 2. And so all of these values gets flipped. 0.1 goes down to the bottom, 7.4 up to the top, and you can see 0.4 goes down here and 2.7 goes up here. So graphically what that looks like is this. All the points get reflected over the y-axis. This is the parent, and now this is the transformed function. What about e to the negative 0.5x? Well, that would be the same thing as your function f of x. F of x is e to the x, remember the parent function. Well, it's basically you're taking this as your input, negative 0.5x. And if you want to rewrite, you're multiplying x by negative 0.5. If you really want to figure out graphically what that's going to do, you have to answer the question, what is x being divided by? And you can rewrite this as a fraction, x divided by negative 2. It's going to be a horizontal dilation by a factor of negative 2. It's going to be, not only will it be reflected over the y-axis negative, because it's a negative dilation, but it's also going to be stretched out by a factor of 2. So you can see that compared to the parent function, the green dot and the yellow dot gets spread out here. The yellow dot, it gets reflected so that 2.7 is up here and 0.4 is down here. All of the x values are twice as far away from 0 as they used to be, and they're also reflected over on the other side. So negative 2 negative 2 times negative 0.5 becomes 1, and that's 2.7. It's up here. The yellow value of 2.7 is now up here. And positive 2 times negative 0.5, that just becomes negative 1. So the green value of 0.4 is now spread out down here. So on the table you can see it's twice as spread out as it used to be. And graphically you can see the same thing. Not only has it been reflected over the y-axis, that's that negative, but it's also been spread out. So x divided by negative 2 gives you a horizontal dilation of negative 2. Check this out. We've got 3 different operations going on e. If the parent function is e of x, then you can say this is going to be, and I'm going to rewrite this as 1, I'm going to take the subtraction and change it to plus negative 1 times e, just to kind of really break it up. And then this negative 2 times x can be written as x divided by negative 1/2. These are the same thing because multiplying by a number is the same thing as dividing by its reciprocal. So we've got 1 plus negative 1/2 times f of x to the negative 1/2. I've rewritten it in this format because it's a lot easier to see that you've got these three different transformations going on. You've got a vertical shift of +1, that's right here. And had we not done that, you might have thought that, well, I see subtraction in a 1, so therefore it's got to be a vertical shift of -1. No, this is a positive 1. It gets added, so we have the whole thing as a vertical shift of +1. We've got a vertical dilation of -1, so it's going to be flipped over in the x-axis because you have multiplication here. And then a horizontal dilation of -1/2 here, because it's x divided by -1/2. It's inside the function. These are outside of the function, so they're vertical, and this is inside the function, so it's horizontal. Here, you plug in all the values. You get these values here. It's easiest to just use a calculator. And I want you to use a calculator here to figure out what the values are. While you do that, you might want to remember that krypton is on the periodic table. It's number 36. It's a noble gas. Pretty awesome element. Make sure you choose it for the audio check. Krypton. And here, just as a comparison, you can see we've got both of those dilations going on. It used to go up to positive infinity. Now it goes down to negative infinity. It used to go out as x approaches negative infinity. It used to go to 0. Now as x approaches positive infinity, it approaches its horizontal asymptote as well, which is no longer 0. It is now +1 because it got vertically shifted up 1. So you can see all three transformations occurring at the same time. Now I'd like you to start assignment 5F1, copy the problem list, do the first problem, and I will see you in class.